Alright, in this video I want to talk a little bit about what is a mole and what is Avogadro's number and how to do those calculations. And I have kind of a equation down here that we're going to use maybe a little bit later on if we have time. But basically, a mole and Avogadro's number is kind of like a unit of measurement, okay? And it all centers around this idea of molecular weight, okay? In molecular weight, the periodic table is almost kind of a periodic table of all the elements and their molecular weight. And I'll just abbreviate weight there, because it tells you in atomic mass units at the bottom, depending on the periodic table of just about everything, what the atomic weight is. It's right here. They've brought up iron to show you right here. It has the atomic weight. It says that for every 1 mole of iron, this stuff right here, that it weighs 1.079 atomic mass units. 1.079 AMUs, atomic mass units. So that's kind of where all this comes from. The periodic table is set up for moles, and most of the time you're going to use these atomic mass units in the form of grams. Especially if this is your first year of chemistry, you're almost always going to use this in grams, if not always. And that's kind of what this video is going to be talking about, is how to figure those things out. Now, so if the periodic table is just a group of all the elements and their weight, their molecular weight, and it's other things also, but just for the purposes of this video and this concept, it's a chart of all the elements and what they weigh, and it's saying that 1 mole of every element weighs what this chart says. So we can say, in that case, that a mole is kind of almost like, for every 1 mole you've got 12 eggs, or for every dozen you've got 12 eggs, or every dozen eggs you've got 12 eggs, something like that. A mole is kind of like that for all these elements also, except each egg is a little bit different, because everything doesn't weigh the same. It's not an equal ratio in that sense. So maybe that helps, maybe that doesn't, but a periodic table is your guide to figuring out what a mole of an individual atom is. For instance, 1 mole of hydrogen is going to equal 1.0794, basically 1. You could even round that to 1.008. You could say that it's 1.008, and we can just slap grams on here. Really, it's atomic mass units, but if we're going to figure, if they ask us to figure in grams, which most of your first year chemistry classes are going to ask you to do, you can say that for every 1 mole of hydrogen, that I have 1.008 grams. So that's if they just give you, the neutral hydrogen by itself. Well, what if they give you, like in this formula here, we have hydrogen H2. Well, that basically is just saying that there are 2 moles of hydrogen. So we know for every 2 moles of hydrogen, we're going to have to double this, right? We're going to have 1.008 grams times 2, right? Because there are 2 moles that we're dealing with. And we can write this out even in dimensional analysis. If you remember from my first video, we started to get into dimensional analysis. We can write out that for every, that we're given, 2 moles of hydrogen, and that we know for every 1 mole of hydrogen, we have 1.008 grams of hydrogen. We're going to multiply 2 times 1.008 grams, divide it by 1 mole. Moles are going to cancel out. It's going to be the same thing as this right up here. And these are going to equal the same thing right here. The exact same thing. Well, I don't know what I did there. These are going to equal the exact same thing. So that's what a mole is saying, right? If it asks us for 1 mole of any given element on the periodic table, that's what it's saying. It's asking us for that. So a little bit of terminology with this, okay? I said that for every 1 mole of hydrogen, it weighs 1.008 grams. Well, this 1.008 grams is called, let me do it in a different color even, maybe green here, is called its molar mass. So if someone that says, hey, what's the molar mass of hydrogen? You're going to say, you'll look at the periodic table, you'll say, well, hey, that's a great question. Looks like the periodic table says it's 1.00794 or 1.008. You'll say the molar mass of hydrogen is 1.008 atomic mass units or grams. So that's where that terminology comes from. You're going to be using molar mass a ton all throughout your chemistry career, mostly depending on what field of chemistry you go into, and all throughout a first year or an introductory chemistry class. It's huge. It's very important that you understand what this is and how to get it using the periodic table. So same thing here. When we did these two equations, we were using molar mass to solve for 2 moles. And this is what you're going to be doing all throughout chemistry. Your Chem 1 class or Gen Chem or an introductory to Chem, this is what you're going to be doing all throughout the class. They're going to be giving you moles of something and asking you, well, what's the weight, how many grams is it? Or they may even throw in an equation or start off giving you grams and all these different ways. And it all starts right here at learning this. So it's very important. Can't stress that enough. All right, so we said that this right here, this H2 by itself was 2 moles of hydrogen. Well, in this equation here, and this is a balanced equation, is what this is called. If you'll notice, oops, didn't mean to erase my hydrogen. There's a 2H2 here, right? It's not just H2, it's 2H2. So how do we write that out? Well, this is basically saying that there are 2 sets of 2 moles of hydrogen. It's kind of like 2 times 2 is what this is saying. So we're going to have 4 moles of hydrogen, right? Because if we have 2 sets of 2 moles of hydrogen, that's going to equal 4 moles total, right? So these 2's right here multiply by each other. It's actually 4 moles of hydrogen. So we can write it out using dimensional analysis even. We can say, well, we've got 4 moles of hydrogen. And we know, using our molar mass ratio here, this is a molar mass ratio, we can say, using our molar mass ratio, that for every 1 mole of hydrogen, I have 1.008 grams of hydrogen. And this is the same as multiplying 4 moles of hydrogen times what 1 hydrogen weighs, right? Which kind of makes sense. I mean, that makes sense. We've got 4 moles of hydrogen that we're working with, and we know how much 1 weighs, so we just multiply it by 4. You know, it's the same thing as if you say, oh, I've got 1 can of spray paint weighs 1 pound. Well, how much does 4 cans of spray paint weigh? Well, it weighs 4 pounds. 4 times 1 is 4. So it's the same thing here. You're taking the weight of this molecule and measuring it by how many parts of the whole being the mole, and saying how much that weighs. So that would equal, you know, basically moles are going to cancel out here. It's going to be close enough anyway to 4 grams of hydrogen. It's going to be 4 point something to be precise, but that's close enough. That'll get us close enough. So all this is great, right? This will get us into moles. Well, there's another, and we get into moles using our molar mass, as you can see in here. Well, there's another ratio that you should really should be familiar with, and you're going to use all throughout chemistry as well. and that's going to be Avogadro's number, or the number of atoms for every 1 mole. And let me kind of draw this out here. I mentioned before that, and I hope I'm spelling this right, Avogadro's number and the mole. And let me switch colors even. Maybe a dark orange. Avogadro's number and the mole. Mole is generally sometimes abbreviated MOL. I'm not misspelling it. That's how you usually write it out in an equation. But I mentioned before about how there's 12 eggs in a dozen. In a dozen of eggs. Well, Avogadro's number is very much just an equation of that. It's saying that for every 1 mole of an element, Avogadro's number, and you know what? Let me even erase this and write it out like that. Avogadro's number states that for every 1 mole of an element, you have 6.022 times 10 to the 23 atoms. So for every 1 mole of an element or a compound even, so for every 1 mole of an element or a compound, you have 6.022 times 10 to the 23 atoms. It's the same thing as saying for every dozen of eggs, you have 12 eggs. Same exact correlation here. So taking our same example up here, let's say I've got one, let's just do hydrogen. Taking our example of hydrogen here, I've got 1 mole of hydrogen, and I know that 1 mole of hydrogen weighs that much. Well, if I have 1 mole of hydrogen, how many atoms are inside that mole? You'd say, well, Justin, that's easy. 1 mole of hydrogen equals 1 mole of anything. 1 mole of hydrogen or whatever equals 6.022 times 10 to the 23 atoms, right? Because I just told you that's what it was right up here, right? This is just a ratio. This is something you'll want to remember for the rest of the semester, rest of your career in chemistry. 1 mole of hydrogen equals 6.022 times 10 to the 23 atoms. You'd write it out using dimensional analysis like this. You'd say 1 mole of hydrogen times, for every one, this is our given right here, given. Let me draw an arrow right there, given, times for every 1 mole of hydrogen, I have 6.022 times 10 to the 23rd atoms of hydrogen. So it would be the same thing as if I told you, all right, here's 12 eggs, and I said, how many dozen is that? Well, you'd say, well, I know for every 1 dozen of eggs, I have 12 eggs. So you'd multiply 12 times 1 is 12, divide by 12, that'd be 1. So you'd have 1 dozen. Same thing here. That's the same exact concept that we're working with here, only we're calling it moles and atoms instead of a dozen and an eggs. So let's kick it up a notch. All right, let me clear out some space here. And you know what, actually, I'm going to save that for the next video. I'm about out of time. So the next video, we'll step it up a notch, and we'll look at more conversions on moles and molar mass and atoms.